All right, so next up we have distance problems. So again, distance has a little bit of a tie-in to physics. So we're going to be looking at a few types of distance problems, but all of them are based off of the general rule of thumb for distance. So distance is equal to your rate, your speed, times your time. Rate times time. So essentially, any distance problem can be boiled down to that formula. Any of them can be boiled down to that formula. It's just depending upon what's in the story. So a truck was able to average 40 miles per hour for the first 4 hours of a delivery route. So think of it this way. So first 4 hours, you have your rate, 40 miles per hour, times 4 hours. That's how long you were going. So that gives you your distance. So that's your distance for the first 4 hours. So of course, then you have the rest of the trip. How long must the driver travel at a speed of 55 miles per hour? So now they want to go 55 miles per hour for the rest of the trip, but we don't know how long that is. To average 50 miles per hour for the entire trip. So you're doing one part of the trip at 40 miles per hour. Now you're doing the rest of it at 55 miles per hour. You ultimately want to average 50 miles per hour for the entire trip. So you have the first part of the trip plus second part of the trip equals total trip. So the first part of the trip was 40 miles per hour times 4 hours. Pretty straightforward. Second part of the trip, 55 miles per hour times some unknown amount of time that you don't know. So if you put it together, you want 50 miles per hour, and then the length of time is 4 plus x. 4 plus x, 4 plus t, whatever variables you choose to use. Key thing to keep in mind here, remember the total amount of time is the first trip and the second trip put together. It's 4 plus x, not 4 times x. So be careful with that. But our algebra is set up. Now it's time to actually do some work. 160 plus 55x, 200 plus 50x. Move the 50 over, so 160 plus 5x equals 200. 5x equals 40. So x equals 8 hours. So that's 8 hours at 55 miles per hour. So if they want to achieve this, that's how fast they're going to have to go. If they want to achieve this, that's what they're going to have. That's how long they're going to have to go 55 miles per hour. So let's keep going. Next scenario. Callie left school and drove to her friend's house at a speed of 40 miles per hour. So we know how fast, we don't know how long. We know how fast, we don't know how long. So in Callie's case, distance equals rate times time. Her rate is 40 miles per hour. We don't know her time. We don't know how much time. Matt left an hour later and traveled 50 miles per hour going in the opposite direction. So we'll take care of the opposite direction in a second. In Matt's case, he is going 50 miles per hour. He left 1 hour later. So that means Callie has been driving an hour longer than he has. Callie's been driving an hour longer than he has. So if Callie's driving T hours, Matt is T minus 1. Because he left an hour later. So he's been driving less time. So opposite directions means Kylie's going one way, Matt's going the other way. It says find the amount of time that Matt needs to travel before they are 400 miles apart. So the distance apart is 400. So that provides you with all the context that you need to now solve this out. So let's do this. So you have Kylie and you have Matt. They're 400 miles apart. So that means there's going to be some addition going on. So Kylie is 40 times t. Matt is 50 times t minus 1. And all together, it has to equal 400. All told, it has to be 400. So there's your equation. That's the equation you're working with. So, time to solve it out. Do the algebra. 40t plus 50t minus 50 equals 400. So 90t minus 50 equals 400. So that's 450, and t equals 50. T equals 5. My apologies. So t equals 5 hours. Now, please keep in mind, that's Kylie's time. It asks for Matt's time. So Matt's time is 5 minus 1, 4 hours. 4 hours. Remember, pay attention. Read and interpret carefully. Read and interpret it carefully. So, next example. Two trains leave their station 304 miles apart at the same time, traveling towards each other. So, don't laugh at my drawing. There's one. There's the other. They are 304 miles apart. They're 304 miles apart. One train is coming at 105 miles per hour. So we know their rate. We don't know their time. T. Another one is coming 85 miles per hour. Know their rate, don't know their time. How long will it take for the two trains to meet? So keep this in mind. Keep this in mind. And I may have shown this incorrectly in one of the classes, so let's correct it now. They're coming on a collision course to each other. They're 304 miles apart. They're going to eventually meet each other. In order to meet each other, they're going to have to make up that 304 miles. They're going to have to cover those 304 miles. Now, the faster train might cover more of it, but in order for these two trains to meet, they have to cover all 304 miles. So that means you can add them up and set them equal to 304 because they still got to cover all of that territory. So 105t plus 85t equals 304. They have to cover all of that distance. They can't meet otherwise. They can't meet otherwise. So, plus side is, this is a fairly easy computation to do. Combine your like terms. So you get 190t equals 304. Divide on both sides so you get a not so nice, well, you get a nice decimal. 1.6 hours. 1.6 hours, they'll meet each other. They'll see each other, they'll meet each other. There you have it. All right, and then one more for distance. A train moving 60 miles per hour leaves the station at noon. An hour later, a train moving 80 miles per hour leaves heading in the same direction on a parallel track. What time does the second train catch up to the first? How long does it take? So you're on a parallel track. You have two trains leaving. So you have train one, train two. They're both on the same track. So train one takes off 60 miles per hour. Do we know how long they've been traveling? No. So that's time. Train two leaves an hour later. So again, T minus 1, just like we did earlier with Matt. But they've been traveling 80 miles per hour. So train one already took off. Train two is now trying to catch them. So in order to catch them, they have to be equal to each other. They have to meet each other. In order to catch each other, they have to meet. No, they have to be equal to each other. So 60t equals 80 times t minus 1. So we've got our equation. Solve it out. 60t equals 80t minus 80. So negative 20t. This time I moved the 80t over. So t equals 4 hours. So that's 4 hours for train one. What time does the second train need to catch up? So train one's going for 4 hours. That means train two, 4 minus 1, 3 hours. Train two's got does it in 3 hours. And that's that. That's it. That's all. So key thing with distance equals rate times time. Distance equals rate times time. Most of the time, you're going to be looking for time. Every so often, you're going to be looking for what speed they are. So it's not completely out of the question. Again, read the problem, interpret the problem, solve the problem. The last video in this set will deal with proportions. We'll do that shortly.